Hello, welcome Eva. Good to have you. Um,
Hello.
so we're gonna get started. I'm gonna record this call for anybody who couldn't make it. So a quick introduction about myself. I am an alum from the class of 2019. I majored in mechanical engineering, minor in design and entrepreneurship, and I love product development. I have experience doing it in startups and companies, and I'm about to start a new job to design humidifier products that you can buy at Target. Um, I'm really passionate about product development, and CAD is one of those tools that it's really useful, right? I'm not an expert by any means, but I like to teach, and I think teaching helps you to helps myself reinforce concepts and reach a higher level of understanding. If I can be helpful to you guys, that would be even better. So with that said, ask me any questions you have along the way. Um, Actually, if you have questions, I would prefer if you just um, put it into the chat. That helps you remember, what question you have, and when I have time, I'll check it out, and then I'll answer it when I find time for a break. Um, cool. So that's that. And to clarify, I'm not a teacher, nor is this a class. I'm just an alum who wants to teach you useful skills that school doesn't teach. Typically, you learn this stuff at internships and doing stuff. So yeah, hopefully some of this is useful to you. Um, so the topic of today, we're gonna talk about CAD obviously, but I'm not gonna lecture you, right? I wanted to show you guys how to design using CAD. So more specifically, I'm gonna share my screen. Um, one second, let me figure out how to share my screen. Um, Share my screen. Okay. All right, then I got. All right. Let me know if you guys can see my screen. Give me a thumbs up. Cool. I got a thumbs up from two people. Eva screen is off, but that's all right. All right. So you guys see you guys see this thing I'm seeing, right? It's a cantilever table lamp. This is actually a pretty cool company. The reason why, so this is hey Eva. So the reason why I picked this lamp is because um, this seems to encompass topics that the majority of the people want to talk about. Somebody mentioned how do you make like like half a hollow sphere, and then another person said she wanted to design lamp, and then some other people just mentioned that like they want to build things related to this thing. So I decided to pick this product to orient our class around. And what's interesting is um, we're going to use 3D CAD to design this product. And this company, Gantry, it's actually a startup that works with designers to design luxury lamps and 3D prints them in their own factory and sells it directly to consumers. So it's a really interesting business. And yeah, so feel free to check them out. If you guys like designing, you can potentially work with them, and if you click, yeah, and you can get lamps into production. Um, so oh, and by the way, like they have somebody at the company that uh, that that is like a 3D modeling expert that works with designers who maybe give them sketches or ideas, and then this designer is going to do what we are about to do to basically design this for manufacturing, for assembly. We're not going to think about those things. That's like the next level, but we're going to uh, yeah, we're gonna just figure out how to design this. Okay. Um, hey Raj, welcome. If you have any questions, feel free to put in the chat. But yeah, but so this is the lamp we're going to design. And so step one, right? So what is this, right? It's a lamp. It's spherical. Let's just scroll down. Let's look at some pictures, right? This is like the front picture. This is the top-ish. Like this is an angled picture from the top. This right here is a picture from the side. And then everything else is just like pretty stuff. This is the design, industrial designer. That's the control. And then you got a bunch of other features, right? What we're most interested in is the front view and the side view. And I'm going to explain why. So when you're designing a 3D object or you're preparing to design a 3D object, step one, you want to kind of think before you touch the tool, which we're going to jump into very quickly. You want to design this thing in your head or on paper, right? So draw it. Think about what is this? You know, what kinds of shapes are here, and what type, you know, how many parts are here, and what materials are being used. Okay. Um, Sometimes you can tell from looking at the picture. Other times you just have to read, right? If you just read the description, read the spec, that gives you a lot of information. Uh, so So I guess let me tell you guys kind of what I'm thinking, right? Like this is a lamp, right? This circular, this spherical part, that's probably where the that probably encloses the light bulb, which and then the spherical part pretty much like diffuses the light. So I'm gonna assume I can't see inside and I don't have the physical product, um, but I'm gonna assume it's hollow, right? So there's this hollow sphere with a bulb somewhere around this area. Um, and if you zoom into this, it's actually not a complete sphere, right? If it's a complete sphere, then it would, yeah, I mean, then yeah, then we'll just fall off. But this right here, it's actually like a. I remember seeing. I think if you like zoom in closer, I think one of these views. I mean, I'm making an educated guess right here, but this right here, it's probably like a cylinder of some sort that extrudes out and connects with this other piece, which looks like a half sphere, right? Right? And these are assumptions. And my goal here is not to make exactly this, but to show you how to do 80%. Um, because if you can make 80% of this, then you're golden. So so that's that. And material wise, like that's this kind of extracurricular, but they have this like special material that's I think like sustainable or something. It's like it's plant based. It's a plant based polymer, you know. So it makes it makes it cool. Again, they sell these for a lot of money, so um so this stuff matters. All right, so we kind of talked about the game plan of well, we talked about kind of what this thing is. Oh, also, so we just talked about, you know, material shapes. Let's think about how many parts there are. Okay, like visibly, right? There's this like normally when you try to tell parts apart, a lot of it's common sense. Um, like so this spherical part, you know, this white spherical part. That's probably one part. The green, you know, half spherical part. That's probably a second part. You know, they're different in color, different in shape. Um, and also I see a split line here, so they're probably separate. And then, you know, because this is a lamp, there's probably a light bulb in here, so that's a third part. And then because, and then, but 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 you also, and then we see a core here, so that's a fourth part. Um, and if any of you guys have experience with electronic, like the lamp, I mean this, or have just used a lamp in general, right? Like this core probably goes directly into the wall plug. Um, And if you guys ever like cut apart that that cord, do it when it's like not plugged in, of course. But if you cut that apart, it's actually pretty interesting. There's things you can learn. Um, if it's two wire, like there's usually at least two wires. One is black, one is red. Black means ground, red means power. So that's for like really basic stuff. I very recently cut open an Apple Lightning core, and I discovered there were four cords, right? So the other two cords are probably used to send some special signals, right? So that was something interesting out there. But my point is that this cord, at the very minimum, it's going to deliver power, but you can't just deliver power directly to the bulb. So there's probably some sort of PCB board that does some sort of voltage conversion um, that converts uh, power from the wall to something that the light bulb can handle. Um, yeah, so I'm just kind of talking through with you guys, kind of what I imagine is inside, right? So we said there's the white spherical thing, the green spherical thing, the core, the light bulb, and then the PCB. So at a minimum, there are five parts, and that's assuming, and we haven't even talked about fasteners, right? I'm not sure how this thing is assembled. If they use fasteners, right, we gotta count every single fastener. If they use glue, right, glue is a material, but right, but that would impact the part count. But yeah, that was just an exercise to kind of think through how many parts we're thinking about. So next, we're gonna get to the exciting part. We're going to start designing. So again, any questions, put it in the chat. But this right here, I want to show you guys a tool that's called Onshape. Um, has anybody used this before? If yes, just throw a thumbs up. Cool. So Onshape, it's pretty awesome. I don't know what computers you guys have or what experience you guys have with CAD, but Onshape is a browser-based OS agnostic 3D modeling tool. What that means is anybody can run it. Like if you can run Google Chrome on your computer, you can run it for free without downloading anything, right? That's pretty magical, right? Um, um, so if you go to onshape.com, you can you can learn all about it. I recommend you to do that later so that you can just focus on this now. But yeah, so let me give you a quickly run through of what we're looking at. Okay, so this right here, I took the step to create a new file. I titled it, and this is what you see when you first create a part, not a part. When you first create a new file, what we're looking at here. So at the top, so in Onshape, sorry, when you're modeling. By the way, before I jump into specifics, one thing I want to mention is I'm teaching you about Onshape right now, but one common question that a lot of you guys ask is, what tool should I use? What's the best tool to learn for 3D modeling? The answer is, um, it's not about the tool. It's about knowing the concept. So if you're good at one tool and you have experience with another tool, which you really should search for, then that experience of transferring the knowledge from one tool to another, it's going to be very valuable because later on when you guys start a job, there's a high chance that your employer is going to use a tool that you've never used before. But if you are comfortable using with one tool, then you should be able to learn it very quickly. That's the exact situation I am in. My employer is using PTC Creo. I have very minimal experience with it, but I feel very comfortable just learning it in a couple of days because I have experienced CADing and I feel comfortable with the general concept. It's a matter of learning where the hotkeys are and what certain tools are called um, in the new environment, in the new tool. So with that out of the way, Onshape is one of many tools. There's SolidWorks, PTC Creo, Onshape, Rhino, Tinkercad, Autodesk Fusion, Autodesk Inventor, right? The list goes on, right? But today we're going to focus on Onshape just because it's such an easy tool for anybody to start with. There's really good resources online. Cool. So now we're going to jump in. So Onshape. Right now we're looking at a bunch of kind of 3D, like three-dimensional tools. So imagine if you had. All right. Actually, I'm going to minimize. The like I'm gonna try to cut to the chase and kind of show you guys how these work. But these right here, they are to turn two-dimensional shapes and like a circle or like a square into something three-dimensional. And then when I press sketch, that's gonna replace all of these with two-dimensional tools. So I can create those two-dimensional shapes. So those are like the two different classes of tools in 3D modeling, right? There are two-dimensional tools. There are tools to make two-dimensional shapes, and then there are tools to make three-dimensional shapes. So I'm gonna and actually, first thing I'm gonna do, I'm going to import. I'm gonna import these photos, right? The front and the side photos. Okay. Ahead of time, I took a screenshot and then I cropped it. So now I'm gonna import them. I like doing this because this lets me use these pictures as references. So first thing first, I'm gonna make a sketch on the front plane. So I click the front plane, hit sketch, and then this right here, this is a cube for you to orient yourself. So so notice how, so when I right click, by the way, a mouse is really useful when you're CADing. So when I right click, that cube turns around, which is at, this is like the orientation cube. So if I hit back, it's gonna zoom to back. If I hit right, it's gonna zoom to right. If I hit top, it's gonna go to top. And then your right click lets you make adjustments. So I think this is the front, yeah, this is the front plane, so I'm gonna go to the front plane. What I'm gonna do first and foremost is to insert the front image. So that's this one. Okay, so this is the front image, and I'm gonna do this. Okay, guess what? We just made we just imported our first photo. Congrats. What I'm gonna do next is to figure out how to dimension it. So in CAD, so there are two different types of colors, actually three. There's like a line could be black, blue, or red. Black means that a line is fully constrained, meaning, yeah, and that's good. Blue, on the other hand, it means it's not fully constrained, meaning, so if I drag this corner, right, I can change it. And that's not good because especially as you begin to design complicated CAD projects, you will likely work with teammates. And when you're working with teammates, you want to hand off something to them that's as constrained and as thought through as possible. So that, because imagine if you sent this to me and you didn't fully constrain this part, then I'm not gonna, then I can manipulate it and just potentially break a lot of things. And that leads to the third type of color, which is red. Red, like you guys all know, it's a warning sign. It's bad. It means something's wrong. So that's what that means. Um, cool. So yeah. So in order to dimension this, I'm actually gonna go back to the website and figure out kind of how big this is. So this tells me that the size is 9.5 inches tall, 8.25 inches wide, and 9.5 inches in diameter. I'm going to assume that 9.5 inches in diameter is referring to the diameter of the sphere, of this big sphere, right? So that's this right here. That's this right here, right? So what I'm going to do is click this dimension, click that. I'm going to punch in 9.5 diameter, right? And what I like about, and notice how when I dimension this, it automatically scaled the entire photo. And that's why I like the photo approach, because you get to take advantage of their aspect ratio to help you design the accent, like the different dimensions and how they're related to each other. Um, so cool. So this is that. Next thing I'm gonna do is to trace this out. Um, I'm going to, so in order to trace it out, I want to, um, I'm gonna start with the circle, right? Because this right here is a circle, right? I'm gonna trace that. Uh, so I know this right here is the center, right? I know this right here is the center point. But by the way, when you hover over lines, sometimes you can see important points like the endpoints, like this, and then you can also see midpoint, right? That's a midpoint. And right now I'm trying to trace the circle. I know the midpoint of this line, but I don't know the midpoint of this line because there's this thing down here. I don't know how tall that is. So again, but like I said, since I'm just shooting for 80%, I'm gonna eyeball this. So I'm gonna click this. I'm gonna bring it up here. Notice how my circle is blue. That's because it's yeah, just because this center point could be anywhere. Now I'm gonna add a relationship between this circle and this line and make it coincident, I think. Coincident means they touch. Oh, but guess what? This cannot work, right? So they gave me an error statement. A coincident constraint cannot be applied to two curves of different types. Okay. So that's so CAD is nice because when you do something that's illegal, so to speak, they tell you right away and they explain why, right? So read these error statements. Okay, so I can't use coincident because they're two different types of lines. Great. Let me try. Okay, I'm gonna try tangent, right? Right. Tangent just means touch at one point, right? That's what I want. So this line and this line, they touch at one point, which is exactly what I want. And now this is fully constrained. And then for this base thingy, I'm going to, yeah, I'm just gonna trace it. So let's see. So because this thing is symmetrical, I'm gonna take advantage of that. So I'm gonna draw a line down the middle and then straight down. Okay, so that get see. So this is like the third type of line that I show you guys. It made everything red. So that means something's broken. Um, let's try to figure out why it didn't let me do that line. Um, that's strange. Let me, yeah, I wonder, I'm not sure why this wouldn't let me do that line. But in CAD, some like this oftentimes happens, and it's important to know how to debug. Um, so yeah, this is kind of confusing to me because it's possible that this whole thing is constrained already, so they don't want me to. Oh, I think I know why. It might have to do with the fact that this line is tangent to this circle. Sorry, this circle is tangent to this line. And when I added that line, it added more points of tangency. Maybe that messed it up. So one thing I'm going to try is I'm pressing Control Z to just reverse. I'm going to try to add this line before. So now I'm back to the point where this is before I added that tangent relationship. I'm going to add that line and see. And if my theory is correct, then this should work. Okay, so that worked. So maybe it did have something to do with the tangent. Let me try the tangent again. See what happens. See, so it was something to do. So this line basically breaks something with that. It breaks the relationship between the tangent relationship between this and this. Um, so that's interesting. So what I can do now instead is because I still want this and this to be tangent. Hmm. Okay, I got it. What I'm gonna do, I'm gonna trim away half the circle, and I'll explain why. Um, that way I only have half of this, and now if I add this tangent relationship, okay, that worked, okay? And I'm gonna explain why I'm only making half of this. Um, so, but first, let's finish tracing the rest of it. Um, so we got this line, we got this line. Um, as you can see, it's not exact, but that's okay. If you look at this feature, it's a pretty nice curve, right? And this curve is so interesting that you probably can replace it with like a simple 3-point arc. So that's when you turn to a function called spline. A spline is basically a really complex curve. So, and the more points you click, the better um, the curve is. So watch that. Cool. So, and when you're done, just hit escape, and then you're done. And splines are a little bit interesting because like there are like for example, this one has 6 points. Six. Well, including well, that's 6 points. Um, and in order to constrain it, you would have to define each of the 6 points. Um, but in interest of time, I'm going to skip that. But that's something you guys should do if you're working with somebody else. So this right here, we sketched half of the lamp, okay? What we're gonna do next is to use the three-dimensional tools that I referred to in the beginning. So first I'm gonna exit out the sketch. And then I'm gonna hit the revolve tool, right? And if you guys can imagine in your head, basically what I'm gonna do is to revolve these two shapes about this line, right? Right? And this is like, I didn't explain why I decided, like when I decided this, but this happened really early. And in CAD, one thing I want you guys to know is that there are many different ways to achieve a certain end result. And there's no right or wrong way, but each of these methods vary in terms of effort, efficiency, and effectiveness. So just pick the one that makes most sense and go at it. Um, yeah, so that's that. So I'm gonna hit the revolve. Um, I'm gonna revolve this guy, and right. So it asks me, okay, which face or sketch region do you want to revolve? This one, and then it asks me revolve axis. Right, that's this one. And look at that, we got our first part, a sphere. Okay. Next thing I want to do, I want to revolve the base, right? So what I gotta so in CAD, I guess in Onshape, I think that the tool assumes that every time you finish using a sketch, that you're done with it, so it automatically hides it. So what I'm gonna do is turn that back on so I can see it. I'm gonna hit revolve. I'm gonna go back to that sketch and select the base, right? So here's where here's where I want to draw your attention to this top here. There are 4 different options here. You can revolve when you're revolving, you can use the revolve to either create a new part, you can add to an existing part, you can remove material, or you can intersect. Okay, what we want to do here is to add a new part, because this goes back to our earlier discussion about how many different parts are there, right? I made the assumption that the sphere is a separate part from the base. So that's that. I'm gonna hit the revolve axis, which is the same as that, right? And then we see something just showed up downstairs. Now I'm gonna hide the sketch to show you guys what we have, okay? So this is what we've got. It's it's a 2-part solid, okay? It's a solid right now. It's not, we've still got quite some way from a lamp, but we got the general shape. Look at that. It's from a designer standpoint, maybe this has a similar aesthetic. um, so in CAD, so let's see, how do I want to do this? So there's a couple of things in my mind that we got to do. Um, one is to hollow out both parts. Another thing is to figure out how these two connect. Right now, if let's say turn off the top part, you can see that the bottom, I think that's like a dome. Yeah, look at that. If we go to the front view, right? If I select this thing and then I go to the front view, you can see that it curves down, meaning this top part just sits on top of it, flush, which is pretty cool. But when you actually designing this thing, you probably don't want it like that, because if the light bulb, it's if the light bulb, gets power from the core and it connects to the PCB board down, which is in the base, and it sits up here, you probably don't want this thing to rotate around, because right now it does that, right? It rotates around. So that's where you want that cylindrical feature. Okay, so let's design that cylindrical feature now. What we're going to do is, let's see, how should we do this? Let me think. Yeah, okay. So what we're gonna do is to design that cylindrical feature that comes from this and mounts onto this. We can do that by first making a new plane. So I'm gonna hit plane, and this plane I'm gonna offset it from the top plane. And I want it to go up to like the midpoint of this sphere. So what I'm gonna do again is to turn on the sketch and then hit that midpoint, right? And then I'm gonna come here, and there are different options for making this plane. I'm gonna choose plane point. This basically means, select a plane you wanna reference, and then a point that you want the new plane to be, where you want the new plane to be, and that's where we're gonna make that plane. And then if I hit OK, it should show up. Where is it? Oh, it's right there. Okay. Right. that plane that we just created is exactly where we want it. It's right. It's parallel to the top plane, and it's exact, and it's right here, right? And the vision is that I'm gonna draw a circle there and then extrude it down to create that base, and I'm gonna add that cylinder to this material so that it's one piece. So ultimately, it's one part, and it's yeah. So let's do that. By the way, one thing I just kind of did this thing on the left. This is called a feature tree, right? As you add features to this project, you're going to this is gonna add up, and you can always like kind of zoom. You can like scroll back. You can roll back, to go back in time, right? I can go to after revolve one, after revolve two, I got the base. After plane one, I got the first plane. So that's how you can like visualize the different features. So this is kind of like a history tree. All right, so let's do what we said we want to do. So I hit plane one, I hit sketch, and then I'm gonna go to top so I can zoom normal to that. And what I'm gonna do now is to make the base, not the base, but I'm gonna make the cylinder piece. Now I don't know how big the cylinder piece should be, but what I do know is that this cylinder piece should be smaller than the base. Okay, so what I'm going to do is I'm going to use a tool here called use/project and convert, and I'm going to use that um, to convert this feature, right? Because that's the smallest feature from the base, and I don't want and that's how that's like that's going to provide the constraint for my cylinder. Okay, I don't want my cylinder to be bigger than that. And by the way, in Onshape, I told you guys about like 3 different types of color. There are also 2 different types of line. These right here are solid lines. Solid lines are used to make your parts, but you can also do you can also turn things into construction lines, which are dashed. And construction lines are used to um, uh, are used for you to make references, which is what we're gonna do now, right? This I only want to use it for reference. I don't want that to be actually the part, right? For simplicity's sake, I'm just gonna make this the nearest round number that's smaller than that. So right now it's 4.25. I'm just gonna make it 4.25. Okay. And then I'm gonna extrude this thing. Right now, I'm gonna right click and just zoom out and see kind of where this is going. Right. So right now this is going up. Right. I don't want that. I want it to come down. So I'm gonna do that. I'm gonna drag it down. How far do I want it to go? Well, let's see. One thing I can do is click on def, and then you can scroll up, and then watch the arrow. I'm moving the arrow, right? Because I'm eyeballing stuff, so kind of guesstimating. So right now it's at 6.3 inches, and it's protruding all the way outside of the base, right? Which is not what we want. So let's go back in a little bit. Cool. So 5 is a nice even number. So let's do that. Cool. So one thing I'm going to do, I'm going to hit P, which hides all the plane. I'm going to hide the sketch because that gets in the way. And look at that. You don't see what I just did, but that's because that feature that we just did, it's hidden inside this. So what I'm going to do is hide this. And now you can see that cylinder that we made. But do you guys notice how this cylinder, when we select it, it's a new part? Guess what? I don't think that's a new part. I think that's actually the same part as this. And because these lamps are 3D printed, that's possible. This would be a pretty complex shape to machine or injection mold it, but because it's 3D printed, this is possible. So what I'm gonna do is go back to this extrude. As opposed to hit new, I'm gonna hit add. And I want you guys to pay attention to this down here. Right now when it's new, this creates a third part, but when I hit add, the third part goes away, and it's red, right? So there's a problem, right? What's the problem? Well, it's trying to figure out which part do you want to add this to, right? Because we have 2 parts. Do you want to add it to the base, or do you want to add it to part 1? Well, I want to add it to part 1. So bam, The red goes away, click OK, bam. We just achieved this thing. By the way, if you write, one thing I like to do, and this, I'm telling you guys these things now because it's good practice, but part one, I don't know what that means. So let's rename it. Let's call this lamp. Lamp, yeah. You guys might be able to come up with better names than me. I'm gonna call that lamp. Part two, I'm gonna call that the base. Cool. So, all right. So it's 3:40. I'm gonna just speed through this. I'm gonna add a quick feature called fillet to just make this nice. Because right now it's like a sharp connection. But if I add a fillet feature, that makes it nice. That makes it just connect in a nice way. It's smooth, super smooth. And then the second thing I'm gonna do is hollow. So if you go to shell, this is how you can make a piece hollow, or this is how you can shell a piece. You want to click the face that you want to remove, and then select the thickness. Right, let's say 1.2. Okay, so that's that. Look inside, it's hollow. Another way to see that it's hollow, you can hit this right here. Go to, whoops, you can hit this right here. You can hit section view. And for section view, this is where planes are useful. You can hit front, which shows you the section view of the front. And look at that. We're looking at half of this thing right now, right? So certified hollow, 100%. If you turn on the base, you can see the difference here. The base is not hollow yet, so that's why you see, yeah, that's the difference. And look at these red things. Red things means they're interfering, right? That's not very good. So what we can do, all right, actually, this is gonna get complicated, and there's definitely more complicated things we can do. But I guess just very quickly, because right now, this, yeah, actually, in the interest of time, because there were other things I wanted to cover. Yeah, I'm just gonna leave it at this. Does anybody have any questions? Yeah, feel free to ask. Feel free to unmute yourself and just ask. Yeah, I'll take questions at this time. Yeah, any questions? Feel free to ask me. This is the yeah.
Yes, I've just have a quick question, Wei. So your like presentation was pretty explanatory, but I was just wondering, like you mentioned that there were 3 different colors
Yeah.
that appeared in Onshape. So I know you said one of them was red. Do you mind repeating what the other 2 were?
Yeah, it's red, blue, and black. Black means it's fully. So I'm gonna go back to the sketch to show you. Here we're showing 2 different colors: blue, black. Red is not here, and that's good. Red means something's broken. You need to fix it. Black means it's fully constrained, and that's good. Blue means it's not fully constrained, and Onshape is still gonna let you do it, like use it, but that's not bad. That's not good practice, because in the future when you're collaborating with your peers, and you send something, you send somebody blue lines, they can watch this. They can drag your blue line and break your part, and and that's just gonna cost you a headache, right? I'm gonna Control Z. Compared to a black line or a black dot, I can't drag this. Why? Because it's fully constrained. So those are the 3 different types of colors. Yeah, and by the way, guys, there's obviously this is just 2 parts, and there's more, right? One thing that I plan to do next is to figure out how to design the base so that it fits the lamp perfectly. So yeah, so we got to hollow. Actually, we hollow it last. First thing I'm going to do is to remove some material, and there's a special tool for that called Boolean that allows you to get rid of this material based on another part, and then we can and if we have other parts like the light bulb, which you can either design the light bulb on your own, which you can definitely design like a simple light bulb on your own, or you can go to an existing service like, let me show you guys. you can go to something like GrabCAD. Has anybody ever gone to GrabCAD? Okay, well, if you guys are gonna design, GrabCAD is a really cool community to um, share 3D modeling things. So GrabCAD, what I'm gonna type in, what I'm gonna search for is a light bulb. There's a chance that like someone has already designed a light bulb. Look at these. You know, somebody designed this incandescent light bulb, and like very recently actually. You can just click this and download it, and then you can import it into this thing, like I did my photos, and then assemble that into your part. And by using that light bulb, you just save yourself some work. So that's something you could do. Um, so yeah, so there's definitely more things we can do here. What I'm gonna do after this call is to share this file with everybody, and I encourage you guys to make an account, play around with it. Actually, I recommend you. I'm gonna give you guys the permission to not edit this file, but to make a copy of this file so that you can make a duplicate of this into your own space and do whatever you want. Okay, I think that's a great way to learn. And you guys can try to edit some of the things I already did and try to just finish this project, right? Try to finish this project and make it as realistic of a lamp as possible. Um, does anybody have any other questions? Okay, if not, I am going to, I want to send you guys a quick survey, okay? It's an exit survey, and we're not over yet. You know, there's just some things I want to talk about, but while we are here, I want to just, you know, get your thoughts on, on this session, okay? So I want everybody to take just, you know, 3 minutes, whatever. There are like 4 questions here. Just fill it out. I really appreciate your feedback. It's gonna help me figure out how to be more helpful in the future. When you're done, hit the thumbs up in the chat, and that lets me know that you're done, and then we can talk about next steps and also some other things. So I'm gonna give you guys 3 minutes, and just let me know when you guys are done.
What do you mean by who's your mentor?
Oh, that's me.
Oh, okay.
Does anybody need more time? Alicia, are you good? Awesome, cool. Thank you all. So next thing I want to, so we got, let me see, we got about 11 minutes, and I'm flexible to stay if you guys have more questions. But there were 3 things I wanted to talk about because in the survey that you guys filled out initially, I asked you guys what questions do you have regarding CAD, and there were kind of 3, and then so I came up with kind of 3 things I wanted to share in response to those general questions, and also this this also doubles as next steps for you guys. Okay, so step 1 is like after this call, if you have time, just make an Onshape account and start playing around. Um, like it's free. It's like a toy. It depends on what you do for fun, but uh, like there's a lot of fun stuff you can do here, and it's free, and you don't need to pay anything. And chances are you can already run it on your machine. So very low barrier to entry. Uh, yeah, and for comparison, like when I was a student, this didn't exist yet, right? Because I was a student about 6 years ago, and I had to use things like SolidWorks and Autodesk, and those things require like a 3-hour download, 1 hour install, and then you have to go through this whole process to get a ticket, like to get a get a seat so you can use it, and it's a pain in the butt. So now it's all you have to do is make an account. That's it. So and then step two, it's that if you want to get better at CAD, it's practice, right? It's a skill, right? It's not like physics and math where you have to sit down and solve problems. Like this, you literally just practice and play, right? So and then the more you play with it, the better you're gonna get at it, right? It's not rocket science. And yeah, and one thing for example, the way I got better at it was that for like a month, I chose something new to CAD every single day. I didn't always finish, but the goal was to try to work on something new every single day, uh, and it doesn't and it could be anything, right? If you guys have questions about what, if you guys want suggestions for what you should build, let me know. But it could be anything, right? It could be as something really simple like this mug. It could be something. It could be like your phone. It could be a mouse. It could be whatever you find interesting. It could be a rocket. It could be this lamp. If you guys play around with this website, there are many other lamps that you can play around with, right? And just do it, right? That's the point of practice, right? Like you don't really need to give yourself a purpose to make a lamp, but if you make it and you really make it intentionally, like think through like how to actually bring this thing to life, right? It's one thing to design something in CAD, but it's another thing to make this in real life, right? And a lot of you guys, I know you aspire to make products that people will use, and in order to reach that goal, you need to be able to think through, okay, what is manufacturing going to look like? What materials am I going to use? How many steps are there in the assembly process, right? Because at the end of the day, if you're going to make thousands plus of these things, someone's going to be on a line making these things, and you gotta think through that as the engineer. And yeah, and last thing is that it's almost like a challenge. Step three is this week I highly encourage you guys to work on something. Pick something, anything. Work on it and share it in the CAD workshop channel. If you have any questions, throw that out there as well. And yeah, share questions you have, share challenges you ran into that you overcame, and any interesting things that you learned, right? This is a community-based community, and like there's so much you can learn by yourself, but you can learn like so much more if you share and encourage others to do so, and learn from each other, right? Because think about it, you guys have, there are 5 people on this call right now. There's probably going to be another 5 to 10 20 people that watch this, because 20 people signed up. And if everybody was to do something like this, then you can learn from 20 people, right? Wouldn't that be awesome? So how do you encourage you guys to work on something, even if it doesn't look as good as you want it to look? Share it anyways, right? That's like failure is the key ingredient to success. And if you want to succeed, you gotta fail, and you gotta fail publicly, and ask for feedback, right? If you fail like in private and you don't show anybody, you pretty much didn't fail because you didn't learn, right? It's all about like the reason why you fail. Failing is good when you can learn from it. That's the pep talk for the day. And yeah, so that's all. Yeah, don't let perfectionism prevent you from sharing. Yeah, just because anything you share, you're gonna learn. Cool. So we're right at 3:55 MIT time. Does anybody have any questions? Anything? Could be about what we talked about today. Could be about um, me. Could be about career. Could be about classes. Any questions? Cool. No, that's all right. Yeah. So if you guys have if any questions ever come up, you know where to find me in Slack. And like I just want to emphasize that I'm not your only resource. The community is. So feel free to message me, but also feel free to send things out to the groups and whatnot. Um, but yeah, so that's all. Thank you all for coming. I hope that was a little bit helpful. I'm gonna follow up with a recording of this conversation and the file, right? I think the file is where you guys are gonna have most fun because you guys get to play with it. Um, cool. Thank you all for showing up, and hope you guys all learned something today. Um, cool. Hope you guys have a good rest of your day.
Thank you.
Yeah, of course.
Thank you.
Of course, of course. All right. All right. Stop share.